So wheat. So let's talk about the numbers for wheat. 1 acre of wheat, 1 acre corresponds to 50 bushels. Correct? Yeah. 1 acre of wheat corresponds to 50 bushels. How much profit will that correspond to? What's the per bushel price of wheat or profit? $2. Correct? Okay. By the same token, can you tell me 1 acre of alfalfa? You know, I have spelled it wrong, but that's okay. $1.5 tons, right? That should correspond to how much is that? 60 profit per acre of alfalfa. And then 1 acre of barley corresponds to 2.2 tons of barley. That should correspond to what's the profit? 50. So it's 50 times 2.2 or 110 profit per acre of barley. So we are doing something like what we did for the Flores problem here, right? So it doesn't even have anything to do with linear programming model. It's just calculating the profitability, right, per acre of each of these crops. It's more like an accounting kind of calculation here. Okay, so but how do you get that into our equation of maximizing the total profit? So we have to go back to the decision variables, right? How are you doing with that? What's that? 7 minutes. Oh, fair enough time. So could I say this? Let's develop the equation or profit for all the wheat that we are going to grow. Okay? All the wheat that we are going to grow, let's try to develop the expression for the profit that we can make from that. Right? What's the per acre profit for wheat? 100. So let's write that. $100. $100 times all the wheat that we grow, correct? Or all the acres of wheat that we grow. I can simply add all of these things. WSE plus WN plus WNW plus WW plus WSW. Isn't it? $100 times each of those things added together should be my total profit from all the wheat that I'm going to grow across all these 5 parcels. Now when we go to form for windows, we'll have to break this up and really say that it is 100 times WSE plus 100 times WN plus 100 times WNW and so on, right? But the idea is that $100 of profit per acre of wheat should be multiplied by all the acres of wheat that we grow across these 5 sectors. So once you know how I have done that, now you know what I'm going to write at home. Okay? 60 times what? Yep. ASE plus AN plus W plus AW plus ASW plus 110 times BSE plus BW, sorry, BN plus BNW plus BW plus BSW. It sounds big, but once you understand what the logic is, it's no more scary. And this is why defining this as what we have defined is helpful, because if we had said x1, x2, x3, x4, x5, there's no way in the world to say how that x1 corresponds to x6. Are we talking about the same sector? Are we talking about the same product? And so on. Cool. So let's write down some of the constraints. As I said, when we do this in LP, you should try this actually. You'll have to split out all of these things, right? So in the objective function, corresponding to all those 15 variables, for the first 15 variables, you will have the number 100, 100, 100, 100, 100. For the next 5 numbers, you will have the coefficient 60, 60, 60, 60, 60. And the next 5 will be, 110, 110. Let's talk about the constraints. And let's do the easy constraints first. Okay? So obviously constraints are going to be of 2 types: resources, and then the marketing kind of constraint, right? Which one do you want to do first? Resources? Okay. So let's talk about the sectors and the sizes of those sectors. Okay. Can you give me at least one constraint? The size of a sector. Which one? Southeast sector is 2,000 acres. Tell me how you write the constraint for that. Perfect. WSE plus ASE plus BSE must be less than or equal to 2,000. That's the sector's constraints. Sector's acreage, right? Constraints. So that's the southeast sector. WSE plus ASE plus BSE must be less than or equal to 2,000. Then WN plus AN plus BN must be less than or equal to 2,300. Do you get the point?
What about the water, the irrigation?
That's why I said we are dealing with the acreage first. Let's just talk about the size first, okay? You cannot grow any more acres than you have available. That's what this is, right? So there are 3 more of these types, correct? WN, so you have WNW plus ANW plus BNW less than or equal to 800. Sorry, 600. W plus AW plus BW less than or equal to 1100. WSW plus ASW plus BSW less than or equal to 500. Perfect. So that is the 5 constraints for the sizes of the sectors. Now we can talk about the water, the usage of the water in each of these sectors, right? So water consumption. Can you tell me the constraint that would say that southeast sector cannot handle more than 3,200 acre feet of water? So I'm going to write this one first. This is easy. Less than or equal to 3,200. So if it was a partial credit, I would get maybe 1 out of 5 points. Absolutely. Good. 1.6 times WSE plus 2.9 times ASE plus 3.5 times BSE. Perfect. It's like the florist shop, right? 4 red roses, 2 gardenias, and 2 carnations make up economy arrangement. So likewise, it's going to be 1.6 times WN plus 2.9 times AN plus 3.5 times BN less than or equal to 3,400. 1.6 times WNW plus 2.9 times ANW plus 3.5 times BNW less than or equal to 800. 1.6 times WW plus 2.9 times AW plus 3.5 times BW less than or equal to 500. And then 1.6 times WSW plus 2.9 times ASW plus 3.5 times BSW, which is less than or equal to 600. Right? So this is for each of those 5 sectors and the water tolerance limit in each of those 5 sectors. But there is one more resource constraint that needs to be taken into account. What is that? The maximum limit on all the water that you can use across all of these sectors and crops. How will you say that? So how much is it? 7,400, right? 7,400. And it is so beautiful. We have done most of it. We just have this whole thing. This is total water used. The left-hand side of all of these 5 constraints together is the total water that will be consumed across all these 15 combinations of crops and sectors. And so that constraint that you write in this model, it's a very nice model when you build it. It will have this 1.6, 2.9, and 3.5 all the way across, for those 15 variables. And that has to be less than or equal to 7,400. That's the total water consumption constraint. The only constraints we have not yet figured out are what? The demand, the sales constraint. So let's do those quickly, and so I don't have to pull one of you to get here to do that on Monday. Sales constraints. Okay, so what's the maximum market for wheat? How many bushels? Okay, let me write that down. 110,000, right? Bushels of wheat. But in reality, because we are talking about acres all the time, how many acres is that? Divide this by 50, correct? So you divide this by 50 bushels per acre. So it's really 2,200 acres of wheat is the demand for wheat, right? 2,200 acres of wheat is the demand for wheat. So the right hand side is 2,200. What's the left hand side? All the wheat, right? So WSE plus WN plus WNW plus WW plus WSW has to be less than or equal to 2200. What about alpha alpha? It is going to be BSE plus BN plus BNW plus BW plus BSW less than or equal to what's the max? 1800 tons, but really 1800 tons is divided by 1.5, right? Tons per acre yield, so that is 1200 acres of alfalfa. And then, oh, this is barley. We can just change A and C. And barley is BSE plus BN plus BNW plus BW plus BSW less than or equal to 2200 tons divided by 2.2 tons per acre or 1000 acres. So those are the three constraints for the demand of this crop. So how many variables are there? 15. How many constraints? 5 here, 6 there, 5 plus 6, 11, 11 plus 3, 14. 15 variables, 14 constraints. I'll tell you the project that I had done for that farm in Indiana had 10 sectors and 5 crops. How many variables? 50. We had all of these constraints there. So 5 sector constraints, 10 sector constraints, 10 water consumption, 1 energy consumption. And then we actually had included some other resources like fertilizers and everything. It still came out to be about 50 variables and 30 constraints problem, and we were able to solve it. Okay? And they actually used it to do the crop planning. So you can find applications of what we learned in places that you would not imagine. Okay? The starting point is how to do this, and that's what we are talking about. Okay, let me give this to you because these are practice problems. I actually have these on the blackboard, but I also had printout, so I'll say instead of you printing it out, I'm just giving it to you.